we've done something that was never done before. And this must be the ultimate upgrade to your Bambu Lab P and X printers. We made the printer bend its own build plate. But that's not all. We also let it open its door, fully automatic. And there's even more. It will protect your worst finger. This is FarmLoop Stage 2. And the best part, I'm showing you exactly how it works and how to build it yourself. If you're new here, I'm Jan, a world record-breaking engineer, and together with my best friend, we've shipped over 20,000 products from our Swiss print farm. But how can we manufacture in the most expensive country in the world and still run a profitable business? With automation. Let's dive in. We recently introduced active plate bending for the H series, which pushed the automation rate up to 90% of our products. For the X and P series, we released our free Stage 1 system that tilts the printer and passively bends the plate. For most parts, it works great. But there are limitations. Number 1, the door needs to stay open for parts to fall out. Engineering materials, or sometimes even PETG, difficult at best. Number 2, maximum part height was limited to 200mm due to the passive bender. And number 3, big surface area parts didn't detach well. The passive flex is just not enough. So we ask ourselves, what if we could build something to solve all these issues? This is where Stage 2 was born. Let's start with the obvious. You didn't buy an enclosed printer to print with the door open, right? Neither did we. That's why we got ourselves a long actuator and mounted it on the side of the printer. 64 newtons of force to reliably open and close the door at the push of a button, or by itself. Now 64 newtons is actually a lot. So what happens if your bratwurst gets in the way? Ouch! That's why we added these two parts on our farm board. Now we can detect sausages or my hand automatically. The actuator detects it and stops immediately. Safety first. But what if you're impatient like me and just want to open the door manually to grab your print? Just pull the safety pin and the door behaves normally. All a matter of the right mechanism. Back to our print. The door's open, but here's the problem. That heated bed is still sitting at 70 degrees and your part isn't going anywhere until it cools down. That's where this little beast comes in. After the door opens, the cooling fan activates to pull in cold air. We did a side-by-side comparison. After printing with PETG, the heated bed starts at 70 degrees. With just the auxiliary fan, it takes around 35 minutes to cool down to 25 degrees. With our additional fan, we cut that by 10 minutes, a 30% decrease. For anyone running P1Ps, the difference is even bigger, since there's no auxiliary fan on those printers. During cooldown, your printer monitors the bed temperature. And once it hits the threshold, it's time to bend. This is the heart of Stage 2. A 50mm linear actuator starts pulling on the plate. Using the new build plate clips, you can even adjust the bending angle. Many parts will instantly pop from the plate. Bigger parts create what's called a peel front. The adhesion breaks progressively from the edge inward. Same principle as peeling off tape off a surface. In our tests, a 2-stage bend was even more effective. An initial bend, short relaxation, then go the full distance. The system runs multiple flex cycles, each cycle working the peel front further across the plate. Most parts, they pop right off. But some need a little bit of help. That's when the pusher engages and clears the part. With our new FarmLoop app, you can even manually set the desired push height. Multicolor parts, prime towers, articulated prints, all cleared automatically. Sounds perfect, right? On paper, yes. But let me tell you what happened a couple weeks ago. I queued up 60 prints and left the farm for the weekend. Everything was running well. And then at print 40 something, the collection box overflowed. Parts started piling up, the door gets blocked and couldn't close anymore, leading to many failed prints. We had to solve that. That's where we introduced the safety check routine. After each print, the door opens and closes once to feel for any resistance. If something is blocking, the bender will immediately retract. And here's why that matters. Bambu printers run a resonance check of the heated bed before every print. With the plate bent, the check will fail. The printer throws an error and stops. After clearing the obstacle, long press the button and you're back in business. With these safety features added, we started mass production in our farm. Obviously, we started with our own parts for FarmLoop and FarmLoop. The PLA parts for FarmLoop were no problem, even with Stage 1. But these holders out of PETG, they were a challenge. With the door always open, we had warping issues. With Stage 2, we can finally mass produce them reliably. This upgrade finally opens the door for engineering materials like PC, PP and even nylon. One example is our multicolor polycarbonate part in our FarmLoop portfolio. We can finally print that in batches. Did we have failures? Of course we did. Most of them came down to one parameter, the Z offset. The Z offset is the distance between the first printed layer and the bed. The bigger the value, the further away the first layer sits, and therefore easier to detach. Bambu Studio doesn't let you change this value, but in our app you can. Don't go overboard though. Push it too far and your first layer won't stick at all. Now we are going too deep into the details. Let's zoom out again and have a look behind the scenes. All these smart features need a brain to pull the strings. That's where our Farm Board 2.0 comes in. The microcontroller on this board detects all the different triggers coming from the limit switch, which is controlled by the movements of the bed. And those movements in turn are inserted by our FarmLoop app. But this board is specifically designed for this task, so how can you build it yourself? But before I show that to you, I want to say something important. Every time we release something, we give you everything to build it yourself. The part list, the firmware code, even the wiring diagrams. But why give all this away for free? Here's how I see it. When you're just starting out, maybe at farm layer 1 or 2, every dollar matters. You're reinvesting everything back into the business. A kit might not be in your budget yet. I've been there. When I started, I was reinvesting all profits to build up the farm and buy filament. That's exactly why we share everything for free. We want you to start automating now, not when you can afford it. Because automation is such a catalyst for future growth. So our philosophy stays the same. Open engineering. Pass the knowledge to the makers and hustlers. But there's one caveat. The safety features of the door opener is not working with off-the-shelf parts. But as you sell more parts and move into farm layer 3 or 4, your time becomes more valuable and suddenly spending a weekend on wiring doesn't make sense anymore. That's where our kit comes in. Either path works. We want you to succeed regardless. What's actually next? This kit works for the P1P, P1S and X1 Carbon. But I know what you're thinking. What about my P2S? We pulled some night shifts and Stage 1 and Stage 2 are both ready for the P2S as well. And beyond that, the H2S and H2D are in testing phase already. Give us 1 more month and we should be ready. In case you're wondering why we are doing all this, here's the simple answer. The bottleneck of 3D print businesses isn't printer speed, it's human time. Our printers run nights, weekends and while we are asleep. And that's an unfair advantage. And we want you to have it too. And while your parts are being printed automatically, you can use the time to learn about marketing, CAD design and how to further grow your 3D print business in our school community. So happy looping, 3D farmers!